Hello everyone, so today I'm going to explain the format and the methodologies used when computing the results of Redstone Awards 2023, co-hosted by Crafty Masterman and Purpulous. And thank you for Crafty for trusting me in computing the results for them as to make this award show a bit more objective, I guess. So let's get started. So let's just summarize the formats used in Redstone Awards 2022. So we have the nomination system as follow. We have 3 private nominations. What do we mean by private nominations? Well, we basically have a nomination form that will be sent to the individual communities, and the nomination form is not public, so only the members within the communities are allowed to nominate who they want, basically. We also allow one nominee from the public nominations, which means that the form is released to the public for the public to choose who they wish to nominate. And for the voting round, we use plurality voting, basically. So plurality voting is simply for people to vote for their best preference, essentially, and then whoever gets the most votes wins. So it's essentially the simplest form of voting, which is widely used in many national elections, basically. Although I will later explain why plurality voting itself is kind of a flawed voting system. There are also more categories within Redstone Awards 2022. Now, compared to 2023, all nominations are now private, which means that only the specialized communities can nominate. The public cannot nominate. We choose to do this in order to increase the objectivity of the awards, obviously, because for public nominations is very much criticized by the general public that it is basically popularity based, although it will still be popularity based somewhat during the voting, but then we wish to decrease the scaling of popularity. So private nominations for all nominees. So that's what we resolved for. Now, instead of plurality voting, which I previously said is a bit flawed, so we opt for basically the best voting system this time, which is the score or range voting. So basically, each nominee will be assigned with a score for every voter, and this nominee with the most score wins. So that's basically score or range voting. There are also less categories, which I will go over now. So this is the summarize of the categories in 2022 versus 2023. So we see that in 2022 there are 2 piston door categories, whereas in 2023 they are basically in 1 category only. Zero-tick remains, and computational, so as many other categories. And more notably, we see that 2022 has the code digger category, which is gone in 2023. Redstone SMP has changed to Redstone Server instead, and Redstone Build of the Year is also gone. Yeah, basically. So we see that Redstone Awards 2023 has less categories, actually. So that's the main format difference. So now I'll explain the methodologies used. So let's divide into 2 parts. The first part will be the nomination methodology. We basically decided that the nominations, each person can only submit 1. So they can only nominate 1 nominee. And with the responses who basically responded with more than 1 nomination in each category will be discarded. So yeah. There's only like 1 to 2 responses with this, so it's not really that big of a deal, or a big of a difference, basically. Now, there's also a check question in the first question, which basically is asking you to please select number 3. And this is ignored because we don't find any significant contribution of this to the effect of the actual results. So we basically ignore this question. And most people already selected number 3, so there's no point in really considering this question's results. So yeah, the top 4 nominees are basically the nominees who get the most nominations will enter the voting round. So that's basically the main methods that we use when deciding on the nominees. So there are still some special adjustments because mostly for fourth place ties. So for piston door and redstone content, there's a fourth place tie. So for piston door, it's between MU222 and Mumbo Jumbo, and we select MU222 to enter the voting round due to better representation in skill. And for redstone content, it's between Avocado and Crafty Masterman, and essentially because Crafty is the event's host, so he decided that it will be somewhat conflict of interest if he is chosen to enter the voting round. So he let out the space to let Avocado to enter the voting round instead. Now for computational, it's more special. We choose Loimei to enter the voting round instead of another nominee, Excavator, who actually has more nominations compared to Loimei, as we find no builds online for Excavator. So unfortunately, we have to let Loimei into the computational voting round instead. So that's basically the special adjustments for the nomination methodologies. So I'll go over the voting methodologies, which is basically the main parts. So again, 1 vote per person. So just like a previous nomination, 1 nomination per person. And we will remove the duplicate responses because duplicates usually mean multiple votes from the same responder. Because even though we have the voting form to be set such that the voter has to log into their Google accounts and can only fill in the form once, we still find some duplicated response essentially. So that's not what we want, and we essentially remove the duplicates. And I'll later explain why duplicates usually mean multiple entries from the same responder. And in this context, responding 0 and leaving it blank are considered 2 different responses. So yeah, basically that. And I also mentioned in the very early part of the video that we choose score or range voting instead of plurality voting. That's because we find multiple advantages to using the score voting system compared to plurality voting system, and also we also compared other voting systems as well, and we find score voting to be the best in this scenario. So yeah, essentially. And we have the range set to 0 to 6 to facilitate uniform voting. I'll explain more in that. And the scores are summed up with scaling adjustments. That's because we find many voters did not use the full range for voting. So essentially, if you did not use the full range for voting, you will have less of your voting value. So we need to scale up because there are too many people who did not vote using the full range. So we basically need some scaling adjustments for that. And lastly, nominee with the most score after scaling adjustment wins. So that's the core of score voting. So yeah, that's basically that. So let's go over each one by one in detail. So why do we remove duplicates? Well, I proposed 2 models essentially on why duplicates should be removed. So we have the strict model, which is basically counting all of the unique votes possible. So we have 10 categories. Each category consists of 4 nominees. And then we have 0 to 6 score, which means there are 7 score possible, plus leaving it blank. So there are 8 possible ways that you can vote for a single nominee. And since there are 40 nominees in total, we basically take to the power of 40. So 8 to the power of 40 of unique votes possible. But then we know that this might not be the case because some votes are basically, you won't do that. So we have a lenient model instead. So we assume that for each category, voters will vote, one or the other, let's say. And we basically assume that each category there are only 2 possible votes. But then there are 10 categories. So we take 2 to the power of 10. So there are 2 to the power of 10 of unique votes possible. And by assuming that these votes are randomly done uniformly, we have over a 99.99% chance for both models of no duplicates given the amount of responses that we have. That is 3,856. So we are very certain that if there are duplicates we can basically be very sure that this is a result manipulation, because in probabilistic counting, this does not make sense. It is very unlikely, so impossible, that there will be duplicated responses. And the only reason we can conclude is because of result manipulation. So that's why we will remove duplicates. And we did find a lot of duplicates, which basically, has some multiple entries, and it's not really that likely that two voters who do not know each other voted the same response. And yeah, basically, due to this rationale, we will remove the duplicates. Now, there are also some other considerations, but then we still come to the same conclusion. We find about 90 duplicates that voted for certain popular nominees. So basically, how they vote is they abstain in voting in any other category except for maybe one or two category where they will vote a selected nominee 6. One or two, essentially. And we basically also remove these because we want to scale down the popularity factor when computing the results, as this is the main goal for us to improve from 2022. So we also remove these for fairer representation, essentially. And another reason is because we essentially have no way of deducing whether this is purely because of popularity or purely because of results manipulation. In both cases, we still want to remove them. So we essentially remove these duplicates as well. So yeah, basically that. And I guess the moral of the story is don't try to manipulate your results by voting more than once using a different Google account, for example, because I'll absolutely be able to detect them. And even for responses with very similar results, I can also detect them. So I didn't remove it this time because I'm a bit more lenient, but then I can still be able to detect them. So just don't try to manipulate your results, because you end up having your responses being deleted even. So that's not helpful for you. So yeah, that's basically the rationale behind the duplicate removal. And I know that some people might think that the models are actually still quite strict, which I agree, because voters don't really vote like this. They may only be interested in one or two categories and just abstain the remainder of the votes. But then I think that having the exact same response duplicated is just simply not possible. So that's also the reason why I did not delete the responses that are very similar but not exactly matching. That's because of considering that the model might not be accurate. So that's why we only removed duplicates instead of similars. So that's the reason why we do that. And now I'm going to explain the comparison of voting systems, essentially. So in 2022, we have this plurality voting system. It's also known as first past the post. Now, when we consider voting systems, we usually look at criteria and perhaps maybe some researches as well. So I'm going to only explain plurality voting and score voting this time, although you'll find some more information in the shared drive link. I will provide it later. But then let's just see how plurality voting performs. So there are a few key criteria that I'm going to look at. Majority, monotonicity, participation, IIA, which means independence of irrelevant alternatives, independence of clones, no favorite betrayal, and also one more, which is not shown in here, which is later no help. Because plurality voting, they only vote for one nominee in each category only. So later no help criteria cannot be applied to here, because it will always need to rank at least 2 nominees or more. So later no help is not applied to plurality voting. But yeah, anyway. So for plurality voting, there are some satisfied criteria. Majority. What is majority? Majority means over 50% of first preference votes. So if a nominee gets that, then the nominee is elected to be the winner. So majority criteria states that. And yeah, plurality voting obviously satisfies that. We also have the monotonicity. Monotonicity essentially means you cannot help a candidate win by not voting for them, or you cannot help a candidate lose by voting for them. So this is the monotonicity criteria. Although it sounds weird that voting systems actually does that, there are actually some voting systems that do not satisfy the monotonicity criteria. Similarly, participation is also a very strange criteria, which essentially states that you cannot gain any advantage by abstaining from voting. While it sounds strange that essentially every voting system should behave like that, there are absolutely some voting systems that do not satisfy this criteria. So again, it's a very strange thing, but then yeah, they exist actually. So that's the participation criteria. So plurality voting satisfies these three criteria. But then there are also some unsatisfied criteria, which is also a reason why I think plurality voting itself is flawed. So there are two similar criteria, IIA and independence of clones. So let's explain what IIA is. IIA, independence of irrelevant alternatives, means that let's say we have three candidates, A, B, C. So if the voting system yields A as the winner, and then we have another hypothetical situation where candidate C is removed, we only have A and B. The voting system should also yield A as the winner. Unfortunately, plurality voting does not do that. We can see this in many in real life elections, the most famous being the US presidential election in 2000, which we have three main contenders, George W. Bush, Al Gore, and the third party, Ralph Nader. And exit votes have basically shown that had people who voted for Ralph Nader choose to vote George W. Bush or Al Gore instead, Al Gore will win instead of George W. Bush. So we can see from this perfect example that plurality voting does not satisfy independence of irrelevant alternatives. And for independence of clones, it's quite similar to IIA, which basically means that if we have more clones or we do not have clones, it should not affect the result of the voting system, or the winner, basically. And plurality voting, as it does not satisfy IA, it also essentially won't satisfy independence of clones. So independence of clones is a more lenient criteria than IIA, but then plurality voting unfortunately does not satisfy both. And by not satisfying these two criteria, we have an effect that is very bad, which is called the spoiler effect, which is essentially what plurality voting is mainly criticized for. And the US presidential election in 2000 exactly showed the spoiler effect. We have also the third criteria that it does not satisfy is the no favorites betrayal. Essentially, no favorite betrayal is saying that you cannot gain any advantage by not voting for your favorites. But then, plurality voting does not satisfy that. The reason is because, let's say if a voter likes a minority party, but then he knows that the minority party are never going to be the top two parties of the election results. What this means is his vote for the minority party will be essentially wasted. And having plurality voting suggests him to instead vote for the majority parties. And By doing so, he betrayed his minority party, which is his favorite. And this is the no favor betrayal being unsatisfied. And we can see from here, it promotes compromising. The voter would compromise to vote for the majority party because voting for the minority party does no help. So, yeah, the compromising promotion is also bad for plurality voting. And in our actual case of Redstone Awards 2023, we actually also see some clones in certain categories. And for the no favor betrayal, you can think of this as popular nominees versus less popular nominees. And by popular, I mean popularity, for example, their exposure in YouTube. So yeah, basically this. And hence, we think that plurality voting isn't really a good system. So yeah, basically that. Now let's compare it to the score voting system. We see that the satisfied criteria is significantly quite a lot. We have essentially all of the criteria satisfied, just now previously said, IIA, with the assumption that all voters vote independently. We also have the independence of clones satisfied. So basically, having more clones or less clones won't affect the results. And we also have the no favor betrayal being satisfied. And one more satisfaction of criteria is later no help. Essentially, basically saying that if you choose to score a voter less, it won't help the nominee. So if you don't vote a nominee, if you vote a nominee with less score, it won't help them in winning. Yeah, that's basically that. Now, there's actually one criteria that it does not satisfy. That's the majority criteria, stating that if there are more than 50% of voters voting first preference to one of the nominee, that nominee should win. This actually, score voting does not satisfy the majority criteria. But then it's actually fine for us to have the majority criteria not satisfied due to score voting's utilitarian property. Essentially, score voting is another way of expressing your utility function. And even though there might be a majority winner, that does not mean that it is a utilitarianly best option. And if our main goal is to make everyone happier, we should maximize the utility function of every single voter combined, which is exactly what score voting does well. So majority criteria not satisfied is actually fine for us, because if we want to make voters more happy, we should opt for score voting and just discard the majority criteria. And by satisfying many criteria, it also minimizes tactical voting. So we can see that for plurality voting, you basically only vote for the first two nominees, and this is tactical voting. And score voting would minimize it, although there are still some existing tactical voting techniques for score voting. We essentially still minimize the effects and people's incentive, you can say. And it's also conducted by researchers and, by criteria comparison that is basically the best of all voting systems if you don't count majority, essentially. So that's why we opted for score voting. So yeah, hopefully this detailed explanation of these criteria will help you understand more on why we select score voting instead of plurality voting. And again, I'll have some resources within the shared drive, but then you can also look at some detailed comparison in this Wikipedia page, which you can basically follow. Now next, I'm going to talk about why do we choose the scores 0 to 6. And essentially 0 is fixed, but then what should be the maximum? Now this comes down a bit of math. Essentially my concept is I want to allow uniform voting for any number of nominees, so 2, 3, or 4, because we have 4 nominees total. And uniform voting is defined as scores that will follow an arithmetic sequence. So example will be 0, 4, 2, so the scores have 2 in difference, and 3, 12, 9, 6, so that is 3 in difference. So yeah, an arithmetic sequence. So there's a theorem which states that if we want to allow uniform voting for all values from 2 to k, then the minimum of all possible maximum score will be the lowest common multiplier from 1 to k minus 1. The proof will be in the reports that will also be in the shared drive. So you can just check out the proof if you can understand mathematical symbols. But then essentially it states that we should pick 6 because k is 4 and the lowest common multiplier of 1, 2, and 3 is 6. So that's basically a mathematical result. So that's why I chose the maximum score to be 6. So yeah. Now let's explain why we need the scaling adjustment. As I previously mentioned, there are many voters who did not use the full range for voting their nominees. And because voters did so, this means that their vote value is less than if you choose to vote with the full range. And all I can say is, as a rational voter, you should either abstain from voting in the category because you feel like your opinion does not matter, or you feel like your opinion may skew the results in a negative way. Or you should vote in the full range, because only by voting in the full range would you maximize the vote's value of yours. So unfortunately, there are too many people who did not vote with the full range, or they abstain in voting. So this shows that voters are not rational, and in lay terms, voters are stupid. So if voters are not rational, what should we do? We should basically do some scaling such that we can see the hypothetical results when the voters are being rational. So hence the scaling process. So the definition here essentially states that the adjusted score will be adjusted from the range that the voter voted to 6. So we have the example 2, 3, 5, 4 will be scaled to 0 to 6, 4. So yeah, you can try to see how you can apply the mathematical formula shown above. And of course, in the special case where the voter abstained from voting in the category, the adjusted score will be 0, because basically the voter did not even vote for anything. So that's basically the scaling adjustment explained. Now, there are still some special adjustments that have to be made after knowing the results of the votes, which is more commonly known as the veto process. We have the veto process in 2022. We also have it in 2023. So let's see why. So there are two very similar ones. So for computational and storage tech, we choose the second place win instead of the first place. Mainly because the first place has no significant contribution to its own respective community in 2023. So that's basically explains that. But then for farm, it's a bit more complicated. We have the third place who win instead of the first or the second place. Now this is due to various considerations, including the popularity of each voter. As we said, we want to scale down the effects of popularity. We want to make the awards more objectively based on scale. So if you are more popular, chances are we will scale down you. We also take a look at the nominations results and the contribution to the technical community, of course, in 2023. And by having these considerations, we think that the third place deserves the most in the best farm designer for 2023. So that's the veto process summarized. Now, the resources, I think that Crafty will also have the raw data and process results released in his own drive, but then my shared drive will have more stuff than his. So my drive will include the raw data, the process results, the summarizing report and slides, including this one, and the actual report that you see that has the definition and theorem, so on and so forth. So, yeah. The summarizing report isn't that long, it's only 2 pages. So, hopefully, that report will basically be more simple to understand. I try to write it in simple words already, which is also essentially the content of the slides. There are also the slides on voting system analysis, so you can basically compare the voting systems that I basically listed and see why I say score voting is the best. There's also one more, which is the detailed analysis of results. Now, this requires a lot of computations, a lot of analysis time, essentially, so it will be staged as to be released. And please expect me to work on it for a couple of months, for example. Guess. So, yeah. Stay tuned for that, hopefully. You will. And yeah, that's basically all I have to say. And thank you for watching this video. Thank you for participating in the Redstone Awards 2023. I truly appreciate it. Once again, thank you for Crafty for trusting me to compute the results for him as to be more objective. And yeah, and I'll see you in my next video.